Hi, this is Mrs. Myers, and I am going to walk you through some practice area problems, a little review for the Chapter 10 test. This is a basic review that I made, just handwritten here, so it's posted so you can print it if you'd like, and I'm just going to go through the problems here. Each figure has, or each polygon has a example problem shown, done out, and then a couple for you to try on your own. So you should try them on your own first, and then watch this video to see if you got them right, and have them explained to you. Okay, so this first one, area is base times height for a parallelogram. So base here is 10, and the perpendicular height is 4, so it's just 10 times 4, or 40 inches, square inches. The second one is twisted. Each side is 12 here. This is 8, but the 8 doesn't have a height that's perpendicular to it. So we have to use the 12 as our base because we're given the height that's 6 that's perpendicular to the 12, the extension of the side that's 12. So base times height here is going to be 12 times 6, which is 72 square. Well, there's no units here, so we'll just say square units. And with number 3 here, this is one of those problems where you have to find h. So again, you're going to have an equal sign, and on one side, on the left side of the equal sign, you're going to put two, let's see, don't show me this message again. Okay. You're going to use the two sides as the base. So I'm going to start with 15 as the base. If I use 15 as the base, I have to look for the height that's perpendicular to that base, because remember, base is always perpendicular to height. So if I'm going to do BH, area equals BH, I'm going to do BH with 15 as B. Height has to be 4 because the 15 and the 4 are perpendicular to each other. Then I'm going to turn the other way and use 5 as the base. Well, if 5 is the base, that's when I use h as the height. So the equation that you're going to end up solving here is 15 times 4, which is 60, equals 5h. Divide by 5 on both sides, and h equals 12. Well, again, I didn't put units here, but height is 12. Okay, so those are the types of problems that you'll have for parallelograms. Triangles. 1/2 base times height is our formula. Again, base and height have to be perpendicular to each other. The basic problem that was given as an example here has a base of 12 and a height of 5. Again, they're perpendicular to each other. We're just doing 1/2 times 12 times 5. We end up with 30 square centimeters. This one is actually a right triangle. So this is that special case that we said base and height have to be perpendicular to each other. Well, the two sides of a right triangle are perpendicular to each other. So base and height end up being 6 and 8 in this case, the two legs. So we have to do 1/2 base times height. So it's a triangle. So 1/2 6 times 8 is 24. We don't use the 10 at all. So this is square units. Number 3, area is 1/2 base times height. Well, we have a lot of sides given to us here. We know this is 20, and this is 18, and this is 25, but we only know one height. They only give us 15 as the height that's perpendicular to the side that's 20. So that's what we have to use. 1/2 base is 20 because it's the only perpendicular height that we're given. So 1/2 of 20 times 15 is 150 square units. moving on, we've got trapezoids. The area formula for trapezoid is 1/2 times h times b1 plus b2. I forgot that parenthesis there. Again, base and height are perpendicular. So remember that there's going to be, oh, and there's a typo, well, a right-o here. I meant to white out this 9, so just cross out that 9 there. That's not the right measurement. Because I wanted to give one where you had to actually solve for the height or solve for something here. Because since the height is perpendicular, it does create a right triangle here. So we are going to do area is 1/2 h times b1 plus b2. Well, we don't know h. We have to solve for h. b1 is 21. b2 different color. B2 is this whole thing. So 30 plus 3 is 33. So B2 is 33. So if this is h, we have to figure out what that is. We're going to use Pythagorean theorem. We have 3 squared plus h squared equals 10 squared. So always look, if you think some dimension is missing, always look for some right triangle that you can use either Pythagorean theorem or special right triangles depending on what's given. Here we are given 2 sides, 3 and 10, and we're solving for the third side of the right triangle. So that means Pythagorean theorem. So 3 squared plus h squared equals 10 squared. We get h squared equals, let's see, this is 9 and this is 100. So 100 minus 9 is 91. So h equals the square root of 91. Let's do that on the calculator. Square root of 91 is, oops, square root of 91 is 9.53. Let's just say 9.5. Height is approximately 9.5. So area formula here, I'm going to have 1/2 times 9.5 times 21 plus 33. Order of operations, we have to do the 21 plus 33 first. So that's 54 times 9.5 times, let's say, 0.5. So on our calculator, we're going to do 0.5 times 9.5 times 54, and we're going to get 256.5. Again, I didn't use units, but remember it's always got to be square units for area. Okay, here's a trapezoid where they give us the base and they give us actually both bases. So we have 1/2 h times b1 plus b2, where b1 and b2 are 12 and 14. They give us those. Again, height is missing. We have to find h. Look for the right triangle. We know the hypotenuse is 5. Do we know this little part right here? Well, they don't give it to us, but we could figure it out. If this is 12, then this has to be 12. And since the whole thing is 14, that just leaves 2 for our little piece of triangle there. So we know this is 2, and this is 5, and this is height. Again, Pythagorean theorem. 2 squared plus h squared equals 5 squared. H squared equals 25 minus 4, or 21. So h is the square root of 21, which is 4.6. So for our formula, we have the height, 1/2 times 4.6 times 12 plus 14. That gives us 0.5. 1/2 is 0.5 times height is 4.6 times 12 plus 14 is 26. So we're going to do 0.5 times 4.6 times 26, and we'll get 59.8 square units. All right, number 3, 1/2 h b1 plus b2. This one, they give us everything we need. We don't need Pythagorean theorem. We're just going to do a straightforward 1/2 height times 10 plus 15. So 0.5 times 8 times 25 is 100 square units. Okay, let's look at the other side. We have rhombuses and kites where our formula is 1/2 d1 times d2, where d stands for diagonal 1 and diagonal 2. The first example here is of a kite. We are given that, oh, that looks like 20, that looks like 2p, but that's supposed to be a 20. That's a 20, and then this is a congruence mark showing that all 4 sides are congruent. That makes it a rhombus. And then one of the diagonals is 24, and that's all they give us. Well, we have to know both diagonals, so we have to know that when we draw in the other diagonal, we're creating a right triangle here. And we're splitting the given diagonal in half, which makes it 12 and 12. So we end up with a triangle like this, a right triangle, where one side's 12, x is what we need to find of the right triangle, and 20 is the hypotenuse. So we do Pythagorean theorem. It turns out that x is 16. Well, remember, 16 is just from here to here. So the whole diagonal is 16 and another 16. So the whole diagonal is 32. So when we plug into our formula, we get 1/2 24 times 32, and we get 384 square centimeters. So for number 2, again, this time both diagonals are drawn, and they give us half of this diagonal is 8. The side is 10. We have to find the other diagonal. Well, D1, if this is 8, we double it to get 16 for one of the diagonals. So now we just need D2. We're going to have to use Pythagorean theorem. So again, this triangle looks like this. We've got 8, x, and 10. We do x squared plus 8 squared equals 10 squared. Turns out x is 6. If you do that out, it'll be x is 6. Well, if this is 6, then the whole diagonal has to be 12. So when we do area, we're going to do 1/2 times 16 times 12, and we're going to get 96 square units. Okay, kites work pretty much the same way, but you have to remember that with kites, it's still right triangles here. One of the diagonals is cut into 2 congruent parts, but the other one is not. So it's a little different than rhombuses. Sometimes you might have to use Pythagorean theorem. Remember the one on the formative? They had a 45-degree angle here, and you had to use that knowledge that you learned in the last chapter. But here they give us pretty much everything we need to know. Diagonal 1 is 3 plus 7, or 10. And diagonal 2 is 2 plus another 2, because they're congruent, so that's 4. So 1/2 10 times 4 is 20 square units. All right, regular polygons. This is the formula 1/2 AP, where A is the apothem and P is the perimeter. The shapes that we focused on were the 3 shapes that contain special right triangles, and they are hexagons, have a 30, 60, 90 triangle in it, right here. Squares have a 45, 90 triangle in it. And equilateral triangles have a 30, 60, 90 triangle in it. This one is facing the other direction. In other words, here in the hexagon, the 30-degree angle is up at top. And here in the equilateral triangle, the 30-degree angle is down the lower angle there. So that's going to change a little bit of how we solve things. For this one, the hexagon, we're told that, what are we told here? That one side is 6. Oh yeah, this was the generic. Um, these 3 diagrams at the top are the generic. They're not actually labeled with any numbers. It's just to show you where the special right triangles are and their relationship. So this is 30 degrees here, side across from it is S, 60 degrees here, the side across from it is S root 3. So the apothem in this one ends up S root 3. The apothem in this one ends up just S because it's 45, 45, 90, and the apothem here is S. So you got to just be careful of those. So then down below here is where the actual problems are. This one we're told that one side is 6. Well, if one side is 6, then, and there's 6 sides, the perimeter is going to be 6 times 6 or 36. The apothem, if we take this special right triangle, I can draw it bigger here. If the whole side is 6, then this little bottom of this triangle is half of that, or 3. And based on the relationship of the special right that we have right here, the side across from 30 is S. So S is 3. That means the apothem is 3 root 3. So when we plug into our formula, we have 1/2 AP. Apothem is 3 root 3. Perimeter is 36. Multiply that out. Remember, keep the root 3 to stick on the end, and you're just going to multiply on your calculator. 0.5, or 1/2, times 3 times 36. Just those whole numbers, multiply them together, you get 54. And then stick the root 3 on at the end if you're asked to give an exact answer. Okay, and on the quiz I do ask you to give, or the test, to give an exact answer. Keep your radical in your answer. Okay, the second one is a square, where they just tell you this little part here is 10. That's the radius of this square is 10. Well, if we're going to look at our triangle there and redraw it here, this side is 10. Well, if that side is 10, and we know it's S, S, and S root 2, this is where it gets a little complicated, right? S root 2 equals 10. That means S equals 10 over root 2. And then you multiply to rationalize the denominator, and you get 10 root 2 over 2, or 5 root 2. So S is 5 root 2. That makes the apothem 5 root 2. This one is probably more complicated than what you'll see on the test. So the apothem is 5 root 2. The side is double that, right? Because this is 5 root 2. This is 5 root 2. Right here, the whole side of this square is twice as much as 5 root 2. So that's going to be 10 root 2. So perimeter is 10 root 2 times 4 sides. 10 times 4 is 40 root 2. So when you actually go to find the area here, we have 1/2 times 5 root 2 times 40 root 2. And you can use a calculator to do this. 1/2 times 5 times 40 is 100. And then root 2 times root 2 is 2. So this whole area turns out to be 200. Okay, the last one here for regular polygons is this equilateral triangle, where they tell you the apothem is 8. Well, again, if I redraw this triangle a little bit bigger, the apothem is 8. Okay, sorry, my phone rang. I had to answer my phone. Let's see. We've got the apothem given to us is 8. And since we are in a equilateral triangle, Our special right triangle hiding in here is a 30, 60, 90 triangle with the 30 down below. So the apothem is S in this case. So the apothem is S, and that's 8. So this bottom part here is going to be S root 3. So it's 8 root 3. Well, in our triangle then, if from here to here is 8 root 3, that means the whole side is twice that, or 16 root 3. Okay, so we have apothem is 8. Perimeter is going to be 16 root 3 times the 3 sides. 16 root 3 times the 3 sides. And if we're going to leave this as exact form, we're just going to do 16 times 3, which gives us 48 root 3 as our perimeter. So we go to do our area formula. We're going to do 1/2 AP, or 1/2. A is apothem is 8. Perimeter is 48 root 3. We're going to do 48 times 8 times 1/2, which is 192, and then stick the root 3 on at the end. That's how you leave it in exact form. Multiply the numbers together, 1/2 times 8 times 48, and then stick the root 3 at the end. So 192 root 3. Okay, last ones here is with circles. 2 formulas, pi r squared, 2 pi r. The first one is done for us. They give us the diameter is 12. We have to figure out that the radius is half of that, or 6. If radius is 6, for area you do pi times 6 squared. That's 36. Stick the pi on at the end. Circumference is 2 pi times radius. 2 times 6 is 12. Stick the pi on at the end. Okay? Number 2, area equals pi r squared. That's going to be pi times 8 squared. 8 squared is 64, so we've got 64 pi. Circumference is 2 times pi times r. 2 times pi times radius is 8. That's 16 pi. Number 3, the diameter is 22. We have to know that the radius is half of that, so 11. Area equals pi times 11 squared, or 121 pi. And circumference equals 2 pi times 11, or 22 pi. Remember, area is going to be square units, circumference is going to be plain old units. Now, if we want to turn any of these into a decimal, we're just going to do 36 times the pi button on our calculator, and then get the answer there. So for this one, 36 pi would be approximately 113.1. 12 pi is approximately 37.7. Okay, and the same thing for the rest of them. Okay, thank you, and good luck.